So we're now going to review the mock midterm for midterm one. Okay. So for part A, they are very much quick fire questions. If you know the theory, these questions should be relatively straightforward of, do you know what your functions are? Do you know your process for limits? Do you know how to compute a natural domain? They should be relatively straightforward questions. And if you know your theory, they should not be too difficult. Okay. So the first question, if we compute the limit as x approaches 3 of x cubed plus 6x plus 9 over x plus 3, we get, if we just plug it in, we get 3 squared plus 6 times 3 plus 9 over 3 plus 3, which is equal to 9 plus 27 plus 9 plus 18 plus 9 all over 6, which equals 36 over 6, which equals 6. So the limit is 6. And you simply just plug it in. Now, for sinh of ln of 5, we get e to the ln of 5 minus e to the negative ln of 5 over 2. This equals 5 minus e to the ln of 5 to the minus 1 over 2, which equals 5 minus 5 to the negative 1 for 2, or 5 minus 1 over 5 all over 2, which equals 25 minus 1 over 25, or over 5, all divided by 2, which equals 24 over 5 times 1 over 2 equals 12 over 5. So we get 12 over 5. Fractions are lovely. If you wanted to do 2.4, you're more than welcome to do 2.4. Okay. Now for our natural domain. For natural domain, we have the ln of x. For this to be positive, x needs to be greater than or equal to 0. And e to the x minus 4 cannot equal 0, which implies e to the x cannot equal 4, or x cannot equal ln of 4. So the natural domain is 0 up to ln of 4, union with ln of 4 to infinity. And you could also write this in set notation of x is an element of the reals such that x is greater than or equal to 4 or greater than or equal to 0, and x does not equal ln of 4. Both of those are okay. Now, computing the inverse of this expression, y equals e to the x to the 7, implies that the 7th root of y, if we switch our x's and our y's, we get x equals e to the y the 7th, which implies that the 7th root of x equals e to the y, which implies that ln of x to the 1 over 7 equals y, which implies that y equals 1/7 ln of x. Okay? Either of these are okay. Okay? So you could have ln x to the 1/7, or you could have 1/7 ln e or ln x. Either of those are okay. Question 5 is asking, do you know your types of discontinuities? So here, one of the directional limits does not exist. So if one of them does not exist at 3, that means we have an essential discontinuity. We don't know what type of essential. It could be an infinite discontinuity. It could be an oscillatory discontinuity. It could be a discontinuity because our function is not defined there. But we have a essential discontinuity. Now we go to the second half of part A. Here we're taking the limit as x goes to infinity of cos of x e to the x. So here, the first thing I'm going to do is I'm going to write the limit as x goes to infinity of e to the x plus e to the minus x over 2 times 1 over e to the x. And I'm just going to simplify this first to figure out what is my function, what's going on here. So the limit as x goes to infinity of e to the x divided by e to the x plus e to the minus x divided by e to the x all over 2, which equals the limit as x approaches infinity of 1 plus e to the minus 2x over 2, which equals 1 plus e to the minus infinity over 2 equals 1 plus 0 over 2, which equals 1/2. So my limit is 1/2. Now we have the arc cos of sine of pi by 4. Now, sine of pi by 4, if we have our special triangles and we get sine of pi by 4, that's going to be 1, 1, root 2. So it's going to be 1 over root 2. And now if we have cos of theta equals 1 by root 2, by our special triangles, theta equals pi by 4. Right? And now we got to figure out which quadrant am I in. We go back to our triangle, we do our dotted lines, we say, okay, I'm positive here, that angle is pi by 4. So my overall angle is pi by 4. And this is interesting because the arc cos of sine pi by 4 is the same as arc sine of pi by 4. This is the only angle that has that property, which is kind of cool. Now, define the intermediate value theorem. So the intermediate value theorem, this is a definition question. We don't really expect you to put it all within this box, okay? We expect you to have some space to define what that theorem is. The intermediate value theorem states that suppose, or let, I guess we should say let, f be continuous over AB and Z lies between f of A and f of B, then there exists a C in the open interval AB such that f of C equals Z. Okay, so what are the other theorems I could ask? I said I could ask you what squeeze theorem is. Define squeeze theorem. Later in this course, we're going to learn mean value theorem, Rolle's theorem, extreme value theorem, Fermat's theorem. We're going to learn a bunch more theorems in the next few weeks. So on the next midterm, there's a larger set of theorems I could ask you to simply define. We do expect you to know your theorems. We expect you to know your theorems and know how to use them. We're not expecting you to know how to prove them. Next, we're going to create a function with this natural domain. And to create this function, what I like to do is I like to just add functions until I get my domain constraints. So the first one is I'm greater than or equal to 0. So I'm going to let f of x equal, I'm going to start with root x. So I'm greater than or equal to 0. Then I'm going to add another function. And this function is going to be defined everywhere except for where I remove another piece. So I don't want to be defined between 2 and 5. So if I do x minus 2, x minus 5, this is going to be a parabola that has roots at 2 and 5. It's because it has roots at 2 and 5, I can use this as my, I want this to be positive. So I'm going to add ln of, and now I'm just going to expand this to make it look pretty. X squared minus 7x plus 10, giving me x squared minus 7x plus 10. And now I can't be between 2 and 5, and I have to be greater than 0. And this is my function. Break it up into those two pieces, remove all the negative values, then remove the values between 2 and 5. And that is my function. And now here, create a function that has an asymptote at x equals 3. F of x equals 1 over x minus 3. Boom, we have an asymptote.